Welcome to my channel. Today we are talking about ChangeNotifier in Flutter in detail. Imagine you're building a simple shopping cart in Flutter. You have a product catalog page, and at the top right, a tiny cart icon displaying the number of items. Standard stuff, right? But here's the catch. The cart item count is stored deep in your widget tree, inside a product card widget 3 levels down. To update that count, you're forced to call stateSet at the very top of your app, triggering a complete re-render of 50 completely unrelated widgets. That's 50 layout passes and paint calls for a single integer increment. Let's look at why this happens and why standard state propagation in Flutter scales horribly. To avoid global rebuilds, developers often resort to prop drilling, passing callbacks down through layers of constructors. In this Dart code, we see the parent state being threaded down through intermediate widgets just so a button can call onChanged. Not only does this bloat your constructors with boilerplate, but it tightly couples your UI widgets to your business logic. If you decide to move the button, you have to refactor 4 different files. There has to be a cleaner, decoupled way to say, hey, this specific data changed, whoever is interested, go ahead and redraw yourself. Enter the observer pattern, a classic software design pattern dating back to 1994. Instead of passing state down manually, we create a centralized subject that holds the state. Observers can register interest in this subject. When the subject updates, it broadcasts a notification to all registered observers, who then pull the updated data. In Flutter, this pattern is built right into the foundation of the framework through a class called Listenable and its most famous subclass, ChangeNotifier. It's a simple, elegant way to establish a one-to-many dependency without tight coupling. Let's write a real ChangeNotifier class. We inherit from ChangeNotifier and define a private variable _cart_count. We expose this via a public getter. Now here is the magic sauce. Inside our addItem method, we increment the count and immediately call notify listeners. This method is inherited directly from the SDK. It iterates through an internal list of active listeners and triggers their callbacks. Crucially, if notify listeners is called when there are 0 listeners registered, it executes in O1 constant time, doing absolutely 0 extra work. But how does notify listeners actually manage these callbacks under the hood? If you open up the Flutter framework source code, you'll find that ChangeNotifier doesn't just use a simple Dart list. Instead, it uses a specialized growable array that handles insertions and removals during iteration. Historically, it used a linked list, but was optimized in Flutter 1.20 to use a flat array to prevent garbage collection overhead. When notify listeners is invoked, it copies the active listeners to a local list to prevent concurrent modification exceptions if a listener tries to unregister itself during the broadcast loop. Now, how does our UI actually listen to this model? The most lightweight built-in way is using an animated builder or a listenable builder. Despite the name, animated builder isn't just for animations. It takes any listenable, like our cart model. When cart model calls notify listeners, the builder's builder function is triggered, reconstructing only this specific subtree. We pass our static icon as a child argument to the builder, ensuring that the icon itself is not rebuilt. Only the text containing the updated counter is redrawn. This is a massive optimization. There is one massive trap waiting for you. Because ChangeNotifier holds a list of strong references to its listeners, failing to clean them up will cause severe memory leaks. If you add a listener inside a stateful widget's init state, you must explicitly call removeListener inside the dispose method. Even better, if you instantiate a ChangeNotifier yourself, you must call its own dispose method to clear its internal listener array and release resources. Neglecting this means your widgets can't be garbage collected, slowly consuming RAM until the OS terminates your app. ChangeNotifier is an incredibly powerful tool when used correctly. Keep your models focused on single responsibilities to avoid over-notifying. Combine it with Listenable Builder for fine-grained widget rebuilding. Always pair your allocations with a matching dispose call to protect your application's memory profile. And remember, for massive enterprise apps, you might eventually look at state packages like Riverpod or Block, but under the hood, they all rely on the exact same core reactive principles we explored today. Thank you for watching this video. Please subscribe and follow.